we're going to look at body fluids. Is a continuation of anatomy and physiology. My name is I'm called Kiden Robina. I'll be taking you through this session. We are looking at body fluids. So generally, in this unit, we are going to have overview of the following: fluid intake and output, body fluids compartments, composition of body fluids, homeostasis. So let us look at fluid intake and output. During steady state conditions, total amount of body fluids and the concentration of solutes remain relatively constant. And to achieve this, intake must be balanced with the output. So the amount of water that you take in must be balanced with what you excrete out. And as we continue, we shall look at that into details. So the daily intake of water, here we have two ways through which water gets into our body. So we can say the major sources of intake. Here we have ingestion, ingestion in form of liquid and water in food. So when we consume food, we are taking in water, can be in form of the liquids that have been prepared, like for instance, if you're eating porridge, if you are taking soup, all that contain water in it. Then also, and this amount of liquid or water that we take in food normally can yield up to 2,200 milliliters per day. So each day, when you eat in the morning, lunchtime, or any time of the day, then supper, you are likely to yield to approximately 2,200 milliliters per day. Then the other way is synthesized in the body. And in this case, we are looking at the oxidation of carbohydrates. The breakdown of carbohydrates, or what we say oxidation of carbohydrates, can yield to about 300 milliliters of water per day into our body. So the total intake of water, the one that we ingest and the one that is oxidized, from produced from oxidation of carbohydrates, can be up to 2,500 milliliters per day. Let's look at daily intake. Let's continue looking at daily intake of water. So water intake variable from person to person. In the same individual, depending on climate, habits, level of physical activity. So it varies. Some people take a lot of water and others do take less. There are people who will tell you that I will take water only when I eat something, or I will take water only like 2 or 3 times in a day. But there are others who depend entirely on water. When they are seated in their offices, they can be sipping water slowly, and that is because their bodies are used to such. Then secondly, in hot environment, hot weathers, normally someone gets dehydrated so fast, and it necessitates the person to take water every now and again. Then also, if the person is very active, like for instance, someone is doing physical exercise or is doing some heavy work, the person ends up taking a lot of water compared to someone who is just seated. So let's look at the daily loss of body water. So we lose our water from our bodies every day. Sometimes we lose knowingly and sometimes unknowingly. So unknowingly is what is called the insensible fluid loss. We don't sense it, but it is being lost every now and again. And here we can talk about things like evaporation. And in evaporation, there are two ways through which water evaporates from our bodies. One is through the respiratory tract. So every time we breathe out, that moisture that comes out together with the air that we breathe out, that comes together with the carbon dioxide, it makes the water to evaporate from our body. That is actually the water that is evaporating from our body. And that kind of evaporation can lead to up to 400 milliliters of water to be lost per day. Then we also lose water through the skin. And through the skin, we can also lose up to 400 milliliters per day. And this, we don't realize it, is insensible. So the total of the two can yield up to 800 milliliters per day. We still continue with the daily loss of body water. So here we look at fluid loss in sweat. So highly variable depending on environmental temperature, level of physical exercise. So when the environment is hot, a human being sweats a lot, and that sweating can lead to loss of large amounts of water from the body. Then when the person is very active, is doing heavy work, the person also sweats a lot and he also loses much water from the body. So normally this loss through body sweat can lead to about 100 milliliters of water per day being lost. So during exercise or hot weather, this can increase to about 1 to 2 liters per hour. Water loss in feces can also be equivalent to around 100 milliliters per day. But the amount lost increases tremendously in cases of severe diarrhea. The person is likely to lose more water than the 100 ml per day that is estimated in a normal person. Water loss by kidneys, this one is variable. Normally can be about 1,500 milliliters per day. So right there we have a table that is showing the daily water balance. We have one side for the water input, as we have discussed before, then also the one for the water output. So specifically those are the figures. So in total, you can say that daily we have water intake of 2,500 and also water loss of 2,500. So in such a case, it means that the water is balanced in the body. In the human body, water accounts for 50% to 70% of the body weight. In general, total body weight correlates inversely with body fat. So that means that the higher the number of the amount of fats in the body, the lower the amounts of water, and vice versa. Thus, total body weight, total body water is a higher percentage of body weight when body fat is low, and a lower percentage when body fat is high. So that one I've already talked about it. Women have more fat, contain less water than men. So total body water of women is 45 to 50% of body weight. However, the percentage can also change depending on the age, sex, degree of obesity. So based on that, the content of the amount of water in the body can change. So you realize that older people have less water in their body than young children. So, like we have said, that women have more water than men. So, children, neonates contain more water than adults. In approximately is 75 to 80% total body weight of the total body weight. So, water makes 75 to 80% of the total body weight in neonates, and for them they have less fats. So that is why newborns have to be properly taken care of so that they cannot suffer from hypothermia since they have less fats. So by about 1 year, body water is equal to 60% of the body weight. So it goes on reducing, as you can see that at the neonatal age is about 75 to 80%. Then as the person grows, when he reaches to 1 year, it now becomes 60%. So it goes on reducing. Body fluid compartments. So the total body fluid is distributed among two major compartments, and those are the intracellular and the extracellular fluid compartments in the body. So the intracellular fluid compartment is contained within the cells, as you can hear the word intracellular, so it is within the cell. So this is contained within the cells and is 2/3 of total body water. So amongst the total body water, or the total amount of water in the body, the water that is found within the cells, or what we can term as intracellular, makes up 2/3, 2 out of 3. Then we have the extracellular. Is outside the cells and is 1/3 of total body water. So the intracellular and the extracellular are separated by the cell membranes. So the extracellular is the one that is outside the cells. Extracellular fluid compartment is further divided into two compartments. We have the plasma and the interstitial fluid. So plasma is the fluid circulating in the blood vessels and is the smaller of the two extracellular subcompartments. So within the extracellular compartment, we have subcompartments. These are the plasma and the interstitial fluid. So the plasma is the one that circulates within the blood vessels and is the smaller of the two. And these can also be termed as intravascular compartment. That is because it is found within the blood vessels. Then we have the interstitial fluid compartment, which is also a subcompartment of the extracellular. And this one is the fluid that actually bathes the cells. So the cells stay in this kind of fluid and is the larger of the two subcompartments. So this one, the interstitial fluid, is larger in amount than the plasma fluid. So let us look into details of the body fluid compartments. The intracellular fluid compartment. About 28 liters of the 42 liters are inside body cells. So intracellular fluid compartment constitutes of 40% of total body weight, which makes up to 70 kilograms in a well-grown up adult, or 2/3 of total body weight, which makes up to 60% of the body water. So right there, we have a table which stipulates clearly about the fluid compartments. We have the intracellular fluid, we said the volume is about 28 liters and it makes 2/3 of the total body weight. Then we have the interstitial fluid. The volume is 10.5 liters and it makes up to 75% of extracellular fluid. Then we have the plasma. The volume is 3.5 liters and it makes up to 25% of extracellular fluid. So this one is clearly stated. So as we had talked about before, that within the extracellular fluid compartment, we have two subcompartments. Those are the interstitial, then we have the plasma, and right there they are well shown. So down there we have a statement that states that total body water that is estimated to be 42 liters and it makes up 60% of the body weight. Plasma and interstitial fluid are separated by the capillary wall. So between the plasma fluid and the interstitial fluid, we have what is called the capillary wall. And this capillary wall is very important for filtration. So it offers what is called ultra filtration. So it allows certain components to pass through, or substances to pass through, to cross over into the cell. So because the capillary wall is virtually impermeable to large molecules such as plasma proteins, interstitial fluid contains little, if any, can be the protein. So for it restricts the movement. It does not allow movement of large molecules. It only allows a few number of smaller molecules to go through. So because of that, there are just a few of the molecules that can be found in right there, and in most cases can be only the protein that can go through. So let's look at blood volume. Right there we have a figure which shows the plasma, and the plasma is said to contain up to 55% of the total fluids. Then we have the leukocytes and the platelets. This, in simple terms, we can say the white blood cells. Then we have the red blood cells, which make up to 45%. So this, when you add the 45% plus the other one, you get around 100%. So right here we have this is a sample that has been taken, a blood sample. So it has been centrifuged, and the red blood cells have settled down. That's because they are heavier. So after the red blood cells, we can see in the middle the leukocytes and the platelets. Then up here, we now have the plasma right there. So this is what it is showing. So let us go into details of this. We look at what is called the hematocrit. So hematocrit is a fraction of blood that is red blood cell. It is determined by centrifuging a sample of blood in a hematocrit tube. So when the blood is centrifuged, erythrocytes are forced to the bottom and the plasma remains at the top. Then leukocyte and platelets form a thin layer in between them, as we have seen right there in that picture. So normal hematocrit, that is 0.4 in men, or 40%. Then in women, it is normally 0.36 or can be equated to 36%. That is why when they take the hemoglobin of women, is normally always lower than the one for men. So in severe anemia, hematocrit falls. In excess production of red blood cells, hematocrit rises. So when the red blood cells are produced in excess due to some medical complications, the amounts can rise, and this can be termed as polycythemia. Then when they drop, maybe because of excessive breakdown or because of certain diseases that can lead to excessive breakdown or severe loss of blood, then that condition can be termed as anemia, as we have seen above. So let's look at compositions of extracellular fluid. So the extracellular fluid is composed of plasma and interstitial fluid, separated by highly permeable capillary membrane. So we have ionic composition also that can be found right there. Then the permeability of protein is small. So small amount of protein leak into the interstitial space. So the interstitial space is that space that is between the cells. Remember earlier I had mentioned that the interstitial fluid is the fluid that bathes the cells. So the fluid in which the cells sit. So right here we have a pictorial which is showing us we have the capillary right there, the plasma. Then here we have the intracellular fluid. Then we have the interstitial fluid indicated right there. So it is the one in which the cells settle. So we are still continuing with the composition of extracellular fluid. So for practical purposes, concentration of ions in the plasma and in the ISF are equal. So the extracellular fluid contain large amounts of sodium and the chloride, then carbonates also. Then they contain small quantities of potassium, calcium, organic acids, sulfates, and the phosphates. Intracellular fluid separated from extracellular fluid by a selectively permeable membrane. So that means that this type of membrane allows certain substances to pass through, whereas it does not allow others to pass through. Mostly molecules that are bigger in size may not be allowed to go through. So it is highly permeable to water, not highly permeable to most electrolytes. So intracellular fluid contains small amount of sodium and chloride. Intracellular fluids contains low amounts of magnesium, sulfates, then large amounts of potassium and phosphorus. So let's look at the ionic composition of body fluids. So right there we have a pictorial that shows us which electrolytes are composed in which compartment. So in the plasma, remember the plasma and the interstitial fluid, they make up the extracellular fluid compartment. So in the plasma, we have the sodium, we have chloride, we have carbonates, then we have potassium. Then the interstitial fluid, the fluid in which the cells are bathed, we have the sodium also, chlorine or chloride, then we have the carbonates and the potassium. So in the extracellular fluid, we have potassium, we have phosphates, we have carbonates, we have chlorine, then we have sodium. So that is the ionic composition of body fluids based on their compartments. So that is it. Let us look at the maintenance of a relatively constant internal environment. So this can be termed as homeostasis. So homeostasis refers to the maintenance of relatively constant internal environment. That means that the input and the output are being maintained at a balance. So the body is functioning well and everything is going on well. The external environment is constantly changing. In order to survive, living things must regulate, compensate, and regenerate. So without the ability to adapt, an animal is limited in its habitat and its performance as a living thing. Any interference with the regulatory system is essentially a disease state. So let's look at the internal environment. All cells of the body, with the exception of those on the surface, are provided with a fluid environment. This constitutes the body's internal environment, commonly known as the extracellular fluid. This we had already talked about. So, internal environment, cells are surrounded by fluid environment. It is known as extracellular fluid. This is the body's internal environment. So here, what it means is that the body's internal environment is it's composed of many things, and amongst them we have fluids. And these fluids, much as they are within the body, but because they are not within the cell, they are termed as the extracellular fluids because they are outside the cell, but they act as the external environment for the cells. So right there in that pictorial, we have the blood vessel right there, as you can see it. Then we have carbon dioxide, then we have glucose. So these pictures that you see in blue, these are the cells, as you can see indicated right there. So we can see that the exchange of oxygen and the carbon dioxide is taking place. Glucose is being taken up by the body cells. So outside the body cells, we have what is called the interstitial fluid, and this makes the external environment for the cells, but it is an internal environment for our body. So we should also note that the conditions are not fixed. Rather, the internal variables are held within narrow ranges. So the conditions are not fixed. So it is not fixed that the person will be in normal status all the time. Anything can change because there are very many factors that interfere with the functioning of the body. So here we can see that our body is assumed to be at a temperature of um, of 37 degrees Celsius, and this is the set point. So this point, uh, if it is set to be 37 degrees Celsius, but it can vary. Sometimes can be lower than that, but sometimes can be slightly higher than that. But of uh, the degree of the change is very, very important. If the change is very grave, then that means that the body is not doing well. So homeostasis is not maintained. So this is a result of actions of carefully coordinated physiological processes. These processes are termed homeostatic mechanisms. So as you can see in this pictorial right there, it means that everything should be balanced. And this is the set point, that line, the orange line in the middle, is the set point. So when we take the temperature, should be around 37 degrees Celsius. So that is the set point for homeostasis to be achieved. So essentially, all the organs and the tissues of the body perform functions that help to maintain these constant conditions. The lungs provide oxygen to the extracellular fluid to continually replenish the oxygen that is being used by the cells. Then the kidneys maintain constant iron concentrations. The gastrointestinal system provides nutrients. So you can see that all systems of the body, they work hard towards maintaining the homeostatic state of the body to make sure that everything in the body is at balance. The respiratory system makes sure that enough oxygen is supplied to the cells for their functioning, and also the carbon dioxide that is produced is excreted out, then it's expired out. Then the kidneys make sure that there are enough or there are constant iron concentrations within the body to put the body at balance. Then the gastrointestinal system is working also hard to make sure that nutrients are in plenty for the body to continue functioning. Homeostatic mechanisms work through feedback systems, and these systems are two. We have the negative feedback and we have the positive feedback. So negative feedback. So here, a change in a variable brings in processes that oppose the change in the variable. So in case of changes in the body works hard to make sure that it brings normality. So that strength or that action that the body takes is what is known as the negative feedback. So it is a control system that acts to maintain a variable within a given range following a disturbance. For example, control of body temperature and the blood pressure. When the body is highly in need of blood, the heart will increase its pumping of blood to make sure that all the body systems are supplied with enough blood for them to continue functioning. And in such a case, you will realize that sometimes the heart starts now working harder, and in cases of constricted blood vessels, if the cause of the body not getting enough blood was constricted blood vessels, you see that when you take the blood pressure, it will raise high. Why? Because the heart is now using a lot of force to make sure that it pumps the blood through the constricted blood vessels. If the body is having if the temperatures of the body are high, for instance, what the body will do is it will try to cool itself down, and this can be done through sweating. The person sweats, then after sweating, the body cools down. So that is those are some of the examples of negative feedback. Though not included here, the positive feedback are those activities where the body does until it achieves its goal. Like for instance, if the mother is in labor, the contractions, once they have started, they will continue until the baby comes out. They will not stop. So that is what is known as positive feedback. Thank you so much for attending um, to this lecture. May God bless you in all your endeavors. Thank you.